everyone, my name is Karuna Singh and welcome to the channel Knowledge Star Continuous Knowledge Excellence. In this video, we will get to know about illustration of the pathogenic bacteria detection. Now, our expert Professor Himadri B, Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Delhi Tiger Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, and biophysics. Will explain you in detail about this topic. So to get complete information, watch full video without skipping.
What is the schematic of the pathogenic detection of bacteria? Now we have the sample matrix here. You have protein, bacteria, lipids, many other things are present in this. It's a assortment of all kinds of things there, analytes. We add magnetic nanoparticles to it, to this dispersion. Now the magnetic nanoparticles will selectively bind to this bacteria here because of the antibodies that are present there. So you have immunogenic separation, immunosuppression of the bacteria from this through the magnetic nanoparticle here. Then you add titanium nanoparticles to it, so that it will make now a complex of the titanium nanoparticle and the magnetic nanoparticle salmonella complex here, this one. So this is a huge complex now we have formed. This is the unbound titanium that is there. Now if you look at the spectra of this one, corresponding to the spectra we started with of the only magnetic nanoparticles, then you will see there is a very drastic change, and that will allow you to do a colorimetric sensing. That's the whole thing. All right. So we have the sample there. First you mix it with magnetic nanoparticle. Magnetic nanoparticles have immobilized antibodies on the surface. They will selectively bind to the bacteria there, salmonella. They'll make this complex. Then a titanium nanoparticle is added, which will again bind to the complex and make these complexes much bigger in size. This unbound titanium is there in the supernatant. Now this is the complex that we need to analyze and then further work on it. Okay, this is gold nanoparticle there. Sorry, magnetic nanoparticle, not gold. This is iron nanoparticle there, the magnified version of this thing, and this is for the titanium. This is the magnetic properties of this material. I will not go into details of this. This only says that.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
The iron nanoparticle that we have made is magnetic in nature. That is the characteristic signature of this thing. Okay, now the binding of this bacteria to nanoparticle. When you bind only to the bare magnetic nanoparticle, which is iron nanoparticle here, you see there is hardly any binding. When it is the surface has immobilized antibodies on it, then the binding is more. This is the bacteria, they are binding more. Now, when it is, we are working with the two nanoparticles together, gold and also titanium nanoparticle, the binding is in fact much more aggressive. And if you look at focus at one area and try to magnify it, and you see so many particles, so many of these nanoparticles are there on the surface. The binding is very, very, very intensive. On the surface of the bacteria, there's huge amount of nanoparticles that are sitting there. Okay, compared to the only magnetic nanoparticle case here. So TiO2 has definitely helped us in enhancing or increasing the binding. More binding means easier detection. You see the detection of salmonella by titanium nanoparticles. The iron nanoparticle concentration has been fixed, and you see with the buffer, there's a linear increase in concentration with normalized value with the concentration of the analyte. This same experiment was done in milk, and you see in presence of the concentration of the salmonella increasing linearly. And from the absorption value, it is easy to find out what is the concentration of the salmonella that is present there. Now, in this particular case, we are not able to do colorimetric sensing because the absorption maximum happens to be at something like 250 nanometer. So 250 nanometer is in the ultraviolet region. Our eye is not sensitive to that. We start visualizing things beyond 400 nanometers only. So this is UV visible detection basically. This is not a colorimetric detection, but the detection of the salmonella.
I hope you liked this video. Here, I would like to give you an important information that Nanoscience and Technology Consortium or NSTC organize the nanotechnology workshops on interesting topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. Okay, one more thing. Do you want full recording of this previous video which you have just seen? Yes? Okay, then contact us at info@nstc.in. Further, to enroll in the upcoming workshops, you can go to the website www.nanoschool.in. So that's all. If you want to see these type of videos, then please do comment. We will definitely reach out to you. And yes, subscribe to the channel Knowledge Star. Hit the bell icon to never ever miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.